Welcome to another informative episode of AWS Solution Architect Associate Exam Question Series on Exam Tricks and Tips channel. Please like, share, and subscribe to get regular updates on new episode releases. Welcome to episode 11. We will cover questions 51 to 55 this episode. For questions 1 to 50, please refer to previous episodes of this series. Let's get started. Question number 51. A web application operating on Amazon EC2 instance in VPC A requires access to files located on another Amazon EC2 in VPC B. Both are distinct AWS credentials. The network administrator must build a solution that enables safe access from VPC A to an EC2 instance in VPC B. There should be no single point of failure or issues about bandwidth. Which solution will satisfy these criteria? This is a question about connecting VPCs. The keywords here are, we have an EC2 instance in VPC A, and that requires access to file located on another EC2 instance in VPC-B. So both EC2 instances are in different virtual private clouds, and we need to make sure we have safe access from VPC-A to VPC-B. This is a very standard scenario explained as per AWS documentation. And you can see here, this is an article from AWS documentation, which talks about two VPCs, and there are certain resources in VPC-A, there are certain resources in VPC-B. And if you have to have any safe connection and connectivity between these two, you have to do VPC peering. A VPC peering connection is a networking connection between two VPCs that enable you to route traffic between them using IPv4 and IPv6 addresses. This is a straightforward textbook scenario for AWS. So let's go to the options. We have seen the solution for this particular problem based on that documentation, and we can see that answer being available at option A. But we'll go through all the options and figure out why other options are incorrect. Option B, it says set up a VPC gateway endpoint for the EC2 instance running in VPC-B. So in the VPC-B, run a gateway endpoint and connect VPC-A to it. Now, to analyze this option, this might not be suitable if you need access to multiple resources in VPC-B or require higher bandwidth. So if you need just one resource, which is the EC2 instance, and you're connecting the VPC endpoint to that EC2 instance, this is fine, but we are not talking about that. And also, this will not give you higher bandwidth. This will involve a public endpoint, and that will increase the security risk. So option B, where we are talking about the EC2 instance in VPC-B using a VPC gateway endpoint, is not a correct one for those reasons. So we rule that out. Option C, it says attach a virtual private gateway to VPC-B and enable routing from VPC-A. Now this introduces a single point of failure within the VPN tunnel and might not offer the same level of control or flexibility as peering. So option C is gone. It's not a suitable option. And option D says create a private virtual interface VIF for the EC2 instance running in VPC-B and add appropriate routes from VPC-B. This option wouldn't work across VPCs, and it limits scalability as it is attached to a single instance. So this is an incorrect option. And we have already seen, based on the documentation that we've gone over, the correct option for this particular scenario is you need a VPC peering connection between VPC-A and VPC-B. And in fact, this is your exam tip. If you get a scenario where you have been given two VPCs and you're connecting resources between these two VPCs, the best solution is you need to use VPC peering between VPC and VPC-B. So that's the answer for this particular question. Set up a VPC peering connection between VPC-A and VPC-B. Let's analyze this particular VPC peering connection from an advantages and characteristics point of view. So the first one is about direct communication. VPC peering creates a private direct connection between your VPCs, allowing instance in each VPC to communicate as if they were on the same network. This avoids public internet access and potential security risks. So this is a very important one. Even though you are two different VPCs, the peering enables is as if it's another virtual private network and you are on the same network, and there is no public internet access, thus increasing the second point, which is why this solution is good, there is no single point of failure. Both VPCs remain independent. So an outage in one VPC will not affect another. Additionally, you can have multiple peer connections for redundancy. So that's a very important fact here. So with this solution, you have basically two VPCs and you are connecting it using peering. At the same time, if VPC-A goes down, VPC-B will function the way it's supposed to be. Yeah, it may not be able to access VPC-A, which is fine, but whatever function VPC-B is able to do on its own, it will continue to do. So there is no problem there. You don't need to have one single VPC peering. You can have multiple VPC peering, and thus you have multiple bridges, and it will add redundancy. So that's another feature to increase the redundancy of the solution. The third bit is high bandwidth, and high bandwidth was one of the requirement in this particular scenario. Peer connections offer high throughput and lower latency, suitable for handling file access efficiently. So that's an advantage. Security, as we have seen already, you can restrict access to security groups within each VPC, ensuring granular control over which instances they can communicate. So this is, using security groups within VPCs to control. And we have also seen in the first point, direct communication, because there is no public internet access involved here. You can have high level of security for this overall solution. So that's it on this question. Let's move on to the next question. Question number 52, a database is hosted on Amazon RDS MySQL 5.6 multi-AZDB instance that is subjected to high volume reads. When evaluating read performance from a secondary AWS region, application developer detects a considerable lag. The developer needs a solution that has a read application latency of less than 1 second. What recommendation should the solution architect make? So let's look at the problem description here and the keywords. So what the scenario we have a database hosted on RDS MySQL 5.6. It's a multi-AZDB instance, and it's subjected to high volume of reads. Now, the problem we have here is developers are detecting a considerable lag when evaluating the performance from secondary AWS region. And now we need a solution that has a read replication latency of less than 1 second. So we need to reduce the time required for read replication. And the metric that we have been given is less than 1 second. And we have been given 4 options here. Let's see what options are suitable, what options are incorrect. Let's look at the first option. First option says install MySQL on Amazon EC2 in the secondary AWS region. Now this will offer some flexibility, but managing self-hosted database across regions introduces complexity and might not guarantee desired sub-second latency. So you cannot install another MySQL instance on another EC2 in secondary region. This is not the correct solution. So we rule that out, and we'll probably come back to these again when we get our final answer. The second incorrect answer for me is, let's look at option C. It says create another RDS MySQL read replica in secondary region. Now we have seen read replica as a solution in scenarios where you have two different types of load, a transactional load and a reporting load on working on the same database. And in order to then improve the performance, you can separate the load and create a replica. This is not that kind of scenario. There is no reporting application here. Replica is not going to help, and it will definitely not help with the sub-second read replication latency. So standard RDS read replica may in fact have higher replication lag exceeding the required latency limit. So read replica is not a solution here. So we rule that out. The next incorrect to me, option D, it says implement Amazon Elastic Cache to improve the database query performance. Now we have seen cache being used in scenarios where you are doing an identical read continuously. So you can use cache, cache the data that is continuously read, repeatedly read, and that will minimize. You don't have to go to the database, read it from cache, and that gives you a good read performance and increases the performance of overall solution. This is not the scenario here. This will improve only in-memory caching for frequently accessed data, as I just told you, but it will not address the replication lag across the region. Which is the core issue here. The core issue here is we have different regions, and we want to make sure that the read replication latency from secondary region is improved to less than 1 second. So that's wrong. And we are left with our final answer here, which is option B. It says migrate the database to Amazon Aurora with cross-region replicas. And that's the correct answer. For sub-second regional read access, you can use Aurora in a cross-region replica configuration. Its architecture ensures low latency and high availability, outperforming with other options while simplifying this overall operation. So that's the correct answer. Whenever you need sub-second regional read access, you can use Amazon Aurora with cross-region replicas. That's the answer for this particular question. So that's it on this particular question. Let's move on to the next question. Question number 53, an e-commerce firm realized that the performance of their RDS-based web application had degraded. The reduction in performance is being ascribed to an increase in amount of read-only SQL queries initiated by business analysts. A solution architect must resolve the issue with the least amount of modification to the current web application. What recommendation should the solution architect make? What is the problem description here? So we have a database that's getting overloaded due to a reporting system that's read operations. It's causing performance issues for primary read write operation. So we have a system where this particular application is accessing Amazon RDS for transactional load, but we also have the business analyst or the reporting application. It's accessing the same Amazon RDS instance for reporting load, and it's reading the data. And because of this, there is an impact on the overall performance of the application. It is slowing down the transactional queries for the main application. And that's the problem we are trying to solve. And we have done this in past multiple times. And you know what the answer is if you have gone through the previous episodes. So what we need to do is, in this scenario, we have two kinds of loads here. So you basically separate your load, create a read replica of Amazon RDS instance, and connect the business application to the read replica. That's the solution for this particular problem. And it's a very common scenario. And every time in exam, you'll get a problem around this particular scenario, that a transactional database is also connected to a reporting load and the overall system is slow and especially impacting the transactional queries. And this is your answer. You need to create a read replica. Let's move on to the question and see what options we have. So we have 4 options here, and let's analyze these options. And we know our final answer, but then let's understand why we are ruling out the other options. So before we start analyzing the option, let's see, do we have our chosen answer based on the solution overview we have just done? So option C is that answer. So we are safe here. Let's see why other options A, B, D are incorrect. So the first one says export the data to Amazon DynamoDB and have the business analyst run the queries. Now, that's not going to work. You're basically saying that you introduce another database here, and that's not going to happen. One of the requirement here, as you can see, highlighted keyword is we want least amount of modification. You don't want to do additional work for just connecting a reporting load. So this is wrong. If you are connecting to DynamoDB, you need to add an additional database for something else, and that's a NoSQL database. So it's a completely incorrect option. The second one, option B, says load the data into Amazon Elastic Cache and have the business analyst run the queries. Now, caching solution can be used where you have a particular application doing identical reads multiple times. So when you cache the data that is being run and on frequent basis, that can be put in cache, and then your application reads from the cache, and the overall number of transactions happening directly with the database are lower, and you ease the load on the database in that solution. This is not that scenario, and you cannot put the whole database in a elastic cache. This is not the application of caching. This is only when identical data sets being used. The scenario here is we have the complete database which business analysts are running reports on. It's not a sample of database or of most frequently accessed data. So wrong application. We do have a solution for the scenario we just talked about, which is the read replica. Let's look at the next option. Option D is another wrong option. It says copy the data into Amazon Redshift cluster and have the business analysts run their queries. Now this will work because you're copying the data in data warehouse, but data warehouse solution is used when you have huge amount of reports to be run. And this is not the application. And we have said for the given problem, we want to make least amount of modification. This is not least amount of modification. And this particular analytics does not qualify for a simple reporting analytics query. It's an overkill for real-time queries, and it will definitely increase cost because Redshift is a very costly solution. So you're using a costly solution which is not needed for an application use case, which is much simpler than that. So option D is wrong. And our final answer is the one we discussed on the solution overview on the previous slide, which is create a read replica for primary database and have the business analysts run their queries. So that's the answer for this particular question. So let's look at the advantages of the option we have selected. So, and let's map it to the requirement. So first one is minimal modification. Creating a read replica doesn't require changes to the existing web application, minimizing the code disruption. So that's one of the beauty of this particular solution, minimum modification. Second advantage, reduce load on primary database. Because of read replica, all your queries for reporting application are going to the read replica. Thus, the overall load of your primary database is reduced because web application is now getting a dedicated access to your primary database, and it improves the performance of all your transactional queries. Cost effectiveness, this is a very cost effective solution when you run heavy analytics on a read replica, because the other option that we had was Elastic Cache and Redshift, which were completely misfit. And even if you try to pull that off, it's going to be a very costly solution. And familiar environment, yeah, most business analysts have SQL skills, so they can always run their queries without learning any new tool. Now, this is not a major advantage, but I think in the mix of things, this also kind of carries some weightage. So that's it on this question. Let's move on to the next question. Before moving on to the next question, if you're finding this analysis and discussion useful, then please hit that subscribe button if you're not already done it. Thank you. Question number 54. AWS Lambda function are being developed and deployed by an engineering team. The team must build roles and administer policies in AWS IAM in order to set the Lambda functions right. How should the team's permission be adjusted to correspond to principle of least privilege? So this is a question on IAM policies, and it has already mentioned that you should be using principle of least privilege. Let's look at the options and also look at the keywords. So we have a Lambda function here. The team wants to build roles and administer policy in order for setting Lambda functions rights. And we need to conform to least privilege. Least privilege means do not give anything more than there is a need or requirement for, and always go for minimal number of options. Do not go overboard and give administrator root or power user access to the resource or the AWS service that we are talking about. So with that in mind, let's jump into the options. So option A, it says create an IAM role with a manage policy attached, allow the engineering team and the Lambda function to assume this role. We are seeing there is a shared role being used between engineering team and Lambda function, and that's not a good idea. With shared role between teams and functions grants unnecessarily access to the team and violates the least privilege principle. So whenever you are doing shared role, there might be a requirement role for, say, one particular resource or service, and then there might be a requirement for Lambda function. And when you create a shared role, you are going to create a superset of role. That means engineering team will have access that they're not supposed to have, but Lambda function has, and Lambda function will have access engineering team supposed to have, but Lambda function is not supposed to have. So this is not correct. As per principle of least privilege, you create granular roles and assign those roles to the specific services or the resources. So this is an incorrect option. We rule that out. Option B is the next one. Create an IAM group for the engineering team with an IAM full access policy attached. Add all the users from the team to this group. Now, in this case, if you see, it says give IAM full access, and that's excessive permissions. We shouldn't be giving anything more than what is necessary. We discussed in the beginning of this question that do not give any administrator root, power user, or anything that gives unnecessary access. So this is wrong. It's a straightforward incorrect option. Option 3 will skip. We'll go to option D. Option D says create an IAM role with a managed policy attached that has permission boundaries specific to Lambda functions. Allow the engineering team to assume this. Now, option D is slightly better than option A. It will still share role between team and functions. So it's basically not correct. It's almost similar to option A in terms of sharing. Even though we are saying, we are going to create permissions boundaries specific to Lambda function, still, you are still allowing another resource to share the role which was not created for it. So that's wrong. It's not as bad, but it is still incorrect. And option C, let's see what does this say. It says create an execution rule for a Lambda function, attach a manage policy that has permission boundaries specific to this Lambda function. So option C is basically option D, but it doesn't share anything with any other, with engineering team or any other resources. So option C is the correct answer for this particular question. We got our answer. Even if you don't know much about IAM, if you follow what does principle of least privilege means, and you should give access that is necessary as per the requirement and nothing more, then you will be able to answer this question very easily. So that's our answer for this particular question. Option C, create a role specifically for Lambda function and attach permission boundaries specific to that only. Do not give any other access. Let's move on to the next question. Question number 55. A business is migrating from on-prem Oracle to Amazon Aurora PostgreSQL. numerous apps write to the same tables in the database. The app must be transferred sequentially with a month between the migration. Management has raised worry about databases heavy read and write activity. Throughout the entire migration process, the data must be maintained in sync across both the databases. What recommendation should a solution architect make? What keywords we have here? We have an on-prem migration scenario from Oracle to Aurora PostgreSQL. There is a need for transferring apps which are writing in the same tables. Apps should be transferred sequentially, and management is worried about the databases heavy read-write activity. The data must be maintained in sync across both the databases. This is quite a detailed scenario. Let's go one by one and analyze these options and figure out what's the correct answer. So let's look at first one. It says use AWS data sync for initial migration and use database migration service to create the change data replication task. This CDC only option is not correct because skipping the initial load might lead to inconsistencies if migration is interrupted. So this option is not correct for that reason. So we rule that out. Option A is ruled out. Next, I think option D. Let's use AWS schema conversion tool for migration with AWS migration service using a compute optimized replication instance. Create a full load plus change data capture CDC replication task and table mapping to select the largest table. And this is the keyword for me because you cannot just use largest tables. So what about other tables? And that means you are basically excluding the tables, and that's going to cause issues. You are not having the full understanding of the overall database as part of this. So this is a wrong option. You're not doing all the tables in this option. So that's wrong. The next one, let's see option C. It says use the AWS schema conversion tool with AWS database migration service using a memory optimized replication instance, which is similar to option D, but just a different type of instance. Instead of compute optimized, we are talking about memory optimized. And create a full load plus CDC replication task and a table mapping to select all tables. Now, while helpful for complex schema changes, it might be unnecessary if schema compatibility is high. Memory optimized instance also might not be the very cost effective. So this is not a correct option. So we rule that out. That leaves us with option B. It says, let's use AWS data sync for initial migration, use database migration service to create full load plus CDC replication task and table mapping to select all tables. So this option is almost similar to option C for almost everything. And it's not from the first part perspective, except for the memory optimized part. And it is creating a full load plus CDC replication task and a table mapping to select all tables. So I think this one is the right option. This particular question is quite difficult. All options kind of look similar, but there are specific nuances here. So option C has memory optimized instance, which is not cost effective. We saw issues with option D as they are only looking at largest tables. And with option A, we saw, skipping the initial full load may lead to inconsistencies. This is a tough one. I would like you to revise this in detail. Answer for this particular question is option B, use data sync for initial migration, then migration service to create full load, plus CDC replication task and a table mapping to select all tables. So all tables is a key keyword here from why this option is the correct one. Let's look at various characteristics and advantages of this particular option. So the first one, it's a phase migration. So data sync facilitates efficient and initial data transfer, minimizing downtime and peak load on the source database during the application callouts. So that's the first one. Full load plus CDC. Combining full load with CDC ensures complete initial data movement and captures ongoing changes for continuous synchronization. All tables, that's a key differentiator between two options. One was going for largest table and this one is going for all tables, option C. Replicating all tables guarantee that data consistency across both the databases throughout the migration, addressing management's concern about that. There was a requirement around that as well. And performance optimization, utilizing DMS optimization like CDC filtering, table splitting to reduce replication workload and minimize performance impact on the source database. So that from a performance perspective as well, this is quite a good option. I will share some links from AWS documentation in video description for you to go over some scenarios around data migration to understand this in bit more detail. That's it on this question. And I believe this is the last question of this particular episode. I'll see you in the next episode of this series soon. Thank you. This is Exam Tricks and Tips. You're watching the AWS Solution Architect Associate Question Series. See you in the next episode. Thanks for watching.